How does the Gintang Tunnel project revolutionize transportation in the East China Sea region, and what makes it a remarkable feat of human engineering? Imagine that incredible things are submerged beneath the waters of the East China Sea. The Gintang Tunnel project is renowned for its incredible potential. This tunnel that cuts straight through the ocean is a feat of human achievement. It's not just any tunnel, though. In addition to being a quicker way to get from point A to point B, it completely transforms how people travel in this part of the world. Come along as we examine this outstanding accomplishment, emphasizing China's inventive engineering and its influence on economic growth and regional connectivity. As the first and longest underwater tunnel for high-speed trains in China, the Gintang Tunnel is a remarkable engineering achievement. This tunnel, situated on the Ningbo-Zhoushan high-speed rail line, is an incredible 77 kilometers long, of which 16.2 kilometers are underwater. The largest and broadest tunnel boring machine, TBM, in the world, Dinghaihao, has made the construction of this tunnel possible. The Gintang Tunnel is a major achievement in China's transportation network since it is intended to dip as deep as 76 meters. It is impossible to exaggerate the significance of the Gintang Tunnel. It is an essential route that connects Jintang, Zhoushan, and Juexi Islands to Ningbo East Railway Station. Improving the region's economic integration and transportation efficiency depends heavily on this connectivity. The tunnel's remarkable engineering capabilities are demonstrated by its ability to tolerate extreme water pressure. Yangzhou, the TBM utilized for this project, was built specifically for it. This enormous piece of machinery is necessary to ensure that the tunnel is built successfully. In addition to being the world's longest and widest TBM, Yangzhou also measures an amazing 11 kilometers in length and weighs an unbelievable 4,350 tons, significantly more than the typical TBM in both dimensions. Underwater tunnel history is an interesting historical adventure that begins in the 1800s. The Thames Tunnel in London was one of the first major undertakings, finished in 1843 after almost 2 decades of arduous effort. This groundbreaking project established the standard for submerged tunnel building in the future. In the 1800s, Napoleon Bonaparte was presented with the concept of a tunnel beneath the English Channel by a French engineer by the name of Mathieu Favier. But it was when the Channel Tunnel was built in the 1960s, connecting France and England, that this dream came true. Submarine tunnels have been built all over the world since then, transforming the transportation industry. It wasn't until the 1960s that the Channel Tunnel, which united France and England, became a reality. Submarine tunnels have been built all around the world since then, transforming transportation. It is genuinely amazing to see how much China has changed and developed over the past few decades, particularly concerning its incredible journey in creating infrastructure. One of the world's biggest and most remarkable high-speed rail networks is currently found in China. Because this network links all of the nation's major cities, traveling around the nation is remarkably simple. People's capacity to communicate and travel has consequently greatly increased. In addition to improving regional connectivity and economic integration, the high-speed rail system has altered how people move and made travel quicker and more effective. Apart from transforming rail transportation, China has also made significant expenditures in urban development. The nation has been building state-of-the-art metropolises with excellent infrastructure. These contemporary cities have high skyscrapers, sleek bridges, smooth roads, and efficient public transit systems. The primary objective is to create modern, sustainable cities that are pleasant places to work and live. China's dedication to raising the standard of living for its people while tackling the problems associated with urbanization is shown in this emphasis on developing high-quality urban areas. Another noteworthy feature of China's infrastructure development is its dedication to sustainability. The nation has demonstrated a keen interest in renewable energy, green building, and sustainable transportation. These initiatives are a component of a larger plan to lower pollution and save the environment for coming generations. China wants to develop a more sustainable future by encouraging the use of electric and hybrid vehicles and incorporating eco-friendly technologies into building construction. This dedication is further demonstrated by large investments in renewable energy sources like hydroelectric, solar, and wind power. Seeing the skyline of a busy metropolis or zooming across China's highly developed rail network at top speed provides verifiable proof of the country's commitment to development and sustainability. China's infrastructure has changed dramatically in recent years, demonstrating the country's determined modernization while placing a high priority on sustainable development and environmental preservation. This dual strategy improves the general well-being of its population in addition to promoting economic progress. The Jintang Marine Tunnel project is a noteworthy illustration of China's excellent engineering capabilities. Part of the bigger Ningbo-Zhoushan high-speed train is this ambitious project. With the use of cutting-edge tunnel boring machinery, the project demonstrates China's capacity to accomplish challenging engineering tasks. The Jintang Marine Tunnel exhibits inventive engineering techniques to handle difficult circumstances beneath the seabed by combining parts of the bridge and tunnel. China's ability to push the limits of contemporary engineering and its proficiency in large-scale infrastructure building are both demonstrated by this project. Another example of how important connectivity and accessibility are is the Jintang Marine Tunnel. The tunnel promotes faster and smoother transit by connecting important areas, which encourages cross-cultural interaction and economic growth. The tunnel's robustness and endurance are ensured by the use of cutting-edge materials and technologies, which can withstand environmental difficulties and high water pressure. China's accomplishments have drawn attention from American engineers as well as the international engineering community. The magnitude and intricacy of undertakings such as the Jintang Marine Tunnel have elicited broad appreciation, underscoring the inventiveness and technological proficiency implicated. These architectural feats raise the bar and encourage other countries to embark on similarly ambitious infrastructure projects. As we look to the future, engineers and enthusiasts alike are likely to be drawn to more groundbreaking infrastructure initiatives across the globe. Technological innovations like the International Thermonuclear Experimental Reactor, ITER, in France, floating cities, and the Hyperloop are daring attempts to use cutting-edge technology to solve contemporary problems. Interest in and funding for the creation of smart cities, which use digital technology to improve urban living, will likewise keep growing. Let's take a closer look at the enormous Dinglihao machine, which is driving major progress on the Jintang Tunnel project. With a width of 14.6 meters and an incredible weight of 4,350 tons, this machine, named Dinglihao, is a marvel of engineering that is the largest and most powerful of its kind in the world. As a vital part of China's ambitious infrastructure plans, the development of the Jintang Marine Tunnel requires heavy lifting, which is the responsibility of this enormous machine. The Jintang Marine Tunnel is distinct due to its unusual design. Its combination of bridge-like and tunnel-like portions, in contrast to traditional tunnels, demonstrates incredible engineering creativity. This creative design, which has never been seen before, demonstrates the cutting-edge potential of contemporary engineering. The building of this tunnel has greatly enhanced the local transportation network and contributed significantly to the overall railway project. In addition to being an engineering marvel, the Jintang Marine Tunnel project marks a critical turning point in China's aspirations to build underwater tunnels and high-speed rail. It is breaking records in terms of both scale and complexity, demonstrating China's commitment to extending the boundaries of what is practical for infrastructure development. The first of many reasons this tunnel is important is the effect it will have on accessibility and connection. The tunnel makes traveling easier for residents, tourists, and companies by joining Ningbo East Railway Station with Jintang, Zhoushan, and Juehua Islands. Improved connectivity makes travel easier and faster, which promotes economic expansion and cross-cultural interaction. It facilitates more efficient transportation of people and goods around the region, which promotes integration and economic growth. Furthermore, this project's usage of Dinglihao demonstrates China's capacity to apply state-of-the-art technology to solve important engineering problems. Dinglihao and other tunnel boring machines are made to withstand the intense water pressure and challenging geological conditions that arise during underwater construction. These devices guarantee the stability and safety of the tunnel in addition to increasing the efficiency of the building process. The Jintang Marine Tunnel connects the high-speed Ningbo-Zhoushan Railway, a vital part of China's extensive rail network. This network is one of the largest and most advanced in the world, connecting significant cities and regions with remarkable efficiency. Travel is now faster and more convenient thanks to China's high-speed rail network, which also significantly boosts the country's economy. Furthermore, the building of the Jintang Marine Tunnel and related initiatives is indicative of China's larger dedication to sustainable growth. China wants to minimize its environmental effects while reducing travel times and improving regional connections through investments in cutting-edge infrastructure. The tunnel is strong and resilient, able to survive extreme weather and high water pressure thanks to the adoption of cutting-edge building materials and processes. Beyond its immediate practical advantages, the Jintang Marine Tunnel project is significant. It represents China's commitment to innovation and advancement in the building of infrastructure. The accomplishment of such a difficult and demanding project establishes new standards in engineering and acts as a template for other infrastructure projects undertaken globally. To sum up, the Jintang Tunnel project's use of cutting-edge engineering skills is demonstrated by the Dinglihao machine. This enormous apparatus is making it easier to build a novel and distinctive tunnel that improves accessibility and connection in the area. China's dedication to pushing the envelope in high-speed rail and underwater tunnel building, shattering records, and establishing new benchmarks in infrastructure development is best demonstrated by the Jintang Marine Tunnel project. This project represents an important milestone in China's continuous modernization and sustainability journey by boosting economic growth and regional connections. China offers excellent urban development in addition to high-speed rail. The nation has been building contemporary metropolises with cutting-edge infrastructure. These cities are known for their soaring skyscrapers, streamlined bridges, seamless motorways, and effective public transportation networks. The goal is to design contemporary, sustainable cities that offer their citizens an excellent standard of living. Notable is China's dedication to environmental sustainability. The nation is making significant investments in sustainable transportation, green buildings, and renewable energy. These initiatives are a component of a larger plan to lower pollution and save the environment for coming generations. China's excellent engineering capabilities and commitment to enhancing its transportation infrastructure are demonstrated by the construction of the Jintang Tunnel. The tunnel is a major advancement in underwater tunnel construction in addition to providing efficient navigation. The utilization of Dinglihao, the biggest and most expansive TBM in the world, demonstrates the scope and aspirations of this project. The Jintang Tunnel project has several difficult engineering problems. Because of its length and depth, the tunnel requires careful planning and construction. The tunnel's ability to endure strong water pressure and probable geological problems must be guaranteed by the engineers. Yongju, the TBM, is specifically made to handle these obstacles. As it moves through the ground, it excavates, clears debris, and installs tunnel segments. The immensity of the work at hand is reflected in Yongju's sheer size and weight. In addition to improving transportation effectiveness, the Jintang Tunnel's successful completion will provide a template for further underwater tunnel initiatives. It illustrates how engineering and cutting-edge technology can overcome major obstacles. The building of the tunnel offers insightful information about overseeing significant infrastructure projects in challenging settings. The Gintang Tunnel is a major accomplishment in China's infrastructure development and a marvel of contemporary engineering. The building of it demonstrates the nation's dedication to advancement, sustainability, and innovation. The tunnel's significance in China's transportation network is highlighted by its ability to link important areas and improve transportation efficiency. With its innovative design, unwavering commitment, and cutting-edge engineering, the Gintang Tunnel is a bright example of what China can do as it continues to develop its infrastructure. Due in large part to the remarkable Ding Haihao leading the project's construction, the Jintang Tunnel project is creating a lot of buzz in the sphere of infrastructure development. With a breadth of 14.6 meters and a staggering weight of 4,350 tons, this enormous piece of machinery is the world's largest and most potent tunnel boring machine, TBM. It is the main engine behind the construction of the Gintang Marine Tunnel, an undertaking that combines tunnel and bridge elements in a novel and inventive way. The Gintang Marine Tunnel is a hybrid marvel that demonstrates cutting-edge engineering methods. It is not your typical tunnel. It is the first of its kind to combine components of a bridge and a tunnel, stretching the limits of conventional infrastructure design. This project is now an essential part of the local transportation network, having sped up the construction of all the railroads in the area. It greatly improves travel convenience for locals, visitors, and companies. The Gintang Marine Tunnel project is unique in that it prioritizes accessibility and connectivity. Travel is made easier and faster by the tunnel, which connects Jintang, Zhoushan, and Zhuexi Islands with Ningbo East Railway Station. Because people and things can move more freely as a result of this better connectedness, economic growth and cultural exchange are predicted. The tunnel's potential to generate significant economic advantages by drawing investments and increasing tourism is highlighted by its strategic importance in connecting important locations. The building of the Gintang Tunnel is evidence of China's inventiveness and engineering prowess. The application of advanced TBMs and submerged tunnel technologies is a prime example of state-of-the-art engineering capabilities. The project showcases how cutting-edge technology can solve major building problems, displaying China's capacity for innovation. Building the tunnel is a demonstration of the ability to carry out intricate, large-scale projects with accuracy and efficiency, not just a means of getting from one location to another. The Gintang Tunnel's increased regional mobility is one of its most important effects. The tunnel improves the flow of people and products by cutting down on journey times and increasing the effectiveness of transportation. Businesses will benefit from this enhancement as they can run more efficiently, and individuals will benefit from more convenient travel. More investments, visitors, and employment possibilities are anticipated as a result of the tunnel, which will support the general expansion and development of the area. Additionally, the transportation network in the area gains an extra degree of security thanks to the Gintang Marine Tunnel. The tunnel ensures that traffic can flow even in the case of an emergency or disruption by offering a backup path. To keep the transportation system resilient and reliable, and to improve the region's readiness for unanticipated catastrophes, redundancy is essential. The Gintang Marine Tunnel is an incredible accomplishment in terms of records. As the world's longest maritime tunnel on a high-speed railway line, it has this distinction. This achievement demonstrates China's capacity to take on and effectively finish some of the most difficult infrastructure projects. In addition to being a major achievement for China, the project raises the bar for submerged tunnel construction worldwide. The success of this project is largely dependent on the Ding Haihao TBM, which was created especially for it. This device is a technological marvel that can install tunnel segments and remove rubbish all at the same time as it bores through the earth. The project requires a high level of engineering knowledge, as demonstrated by the size and complexity of operating such a large machine. The Gintang Tunnel's successful construction process highlights the value of specialist machinery in contemporary infrastructure projects with the use of Ding Haihao. The Jintang Marine Tunnel project is proof of the effectiveness of cutting-edge engineering and technology. Ding Haihao and Yongzhou, two tunnel boring machines, TBMs, are at the center of this innovative project. These devices are made specifically for subterranean tunneling. They can endure extremely high water pressure and guarantee accurate and efficient construction. These TBM's durability enables them to drill through the ocean floor and build the tunnel without endangering structural integrity or safety. Technology for shield tunneling is yet another essential element of this endeavor. By erecting a protective barrier around the tunnel boring activities, this cutting-edge technology protects the environment and the workers. It guarantees the structural stability of the tunnel and permits accurate drilling beneath the ocean floor. The development of shield tunneling technology is essential to the viability and safety of underwater tunnel construction. Sophisticated underwater building methods, such as underwater welding, concrete laying, and continuous monitoring systems, are also used in this project. The exact placement of concrete increases the strength and endurance of the tunnel, while underwater welding guarantees that the segments are bonded firmly. Monitoring systems, comprising cameras, sensors, and real-time data processing tools, are used to make sure that every facet of the construction process is closely monitored. By keeping an eye on things constantly, possible problems can be quickly identified and resolved, keeping the project safe and on schedule. Modern monitoring systems are essential to preserving effectiveness and safety. These technologies give engineers up-to-date information on the state of the tunnel and warn them of any possible issues before they get out of hand. With the use of cutting-edge technology, the construction process can be continuously monitored, guaranteeing that the tunnel will be able to survive the difficulties presented by its underwater environment. The Jintong Marine Tunnel's creative layout and selection of materials are equally remarkable. High-strength materials, resistant to corrosion and stresses of underwater environments, including seismic activity, are used in the construction of the tunnel. These components are essential to guaranteeing the tunnel's robustness and lifespan, able to survive the severe conditions of the maritime environment. The Jintong Undersea Tunnel project has garnered attention from the engineering community, especially in the United States. The sheer ingenuity and ambition underlying this enormous infrastructure project astound American engineers. Many people have expressed respect for the project's size and complexity, citing the groundbreaking engineering achievements that are being accomplished. The Jintang Marine Tunnel's extensive range of applications beyond daily use is another outstanding feature. By offering a backup route in the event of emergencies or other unanticipated incidents, this tunnel considerably enhances the local transportation infrastructure and guarantees ongoing operations. It also has the distinction of being the longest maritime tunnel on a high-speed rail route in the entire globe. This accomplishment highlights China's capacity to take on and finish even the most difficult infrastructure projects, shattering previous records and creating new ones in the process. In many respects, the Jintang Marine Tunnel project is groundbreaking. It fosters innovation, increases connectivity, fosters economic growth, and improves regional transportation. The project demonstrates China's dedication to developing its infrastructure and its capacity to incorporate state-of-the-art technologies into its development strategies. The cutting-edge technology propelling this massive project's success is at its core. Tunnel boring machines, TBMs, like Ningbo-Zhoushan and Yangzhou, are essential to the building of the Jintang Marine Tunnel. These devices, which can tolerate extreme water pressure and enable extremely effective tunnel building, are specially made for underwater tunneling. Ningbo-Zhoushan, with its width of 14.6 meters and weight of 4,350 tons, is a prime example of the complex engineering involved in this project due to its sheer size and power. Shield tunneling is another essential technique included in the project. During excavation, this advanced method guarantees both the integrity of the tunnel and the safety of the workers. With shield tunneling, precision drilling below the water's surface is possible without endangering the ecosystem nearby or the tunnel's structural integrity. This technology is essential to preserving the fine balance between environmental protection and infrastructural advancement. Innovative underwater building methods, like underwater welding and concrete placement, are also used in the construction process. These techniques are necessary to guarantee the stability and longevity of the tunnel beneath the sea. Modern monitoring systems, which include cameras, sensors, and real-time data processing tools, Keep tabs on the construction project's advancement to make sure it stays on schedule and that any possible problems are dealt with right away. The tunnel's resistance is further increased by the use of cutting-edge materials in its construction. High-strength materials are used to resist a variety of environmental stresses, including seismic activity and corrosion. The tunnel will continue to be secure and operational for many years to come because of this emphasis on longevity. All things considered, the Jintang Marine Tunnel Project is a major advancement in the field of infrastructure development. It is evidence of China's engineering expertise and dedication to enhancing transportation infrastructure. Along with making transit easier and more effective for locals, companies, and visitors, the tunnel is essential to improving regional connection and economic integration. To sum up, the Jintang Marine Tunnel is a groundbreaking project that uses cutting-edge technology to accomplish incredible technical achievements. Every element of the project, including the potent tunnel boring machines, advanced shield tunneling technology, and creative underwater building methods, is planned to guarantee durability, efficiency, and safety. This tunnel is a prime illustration of how innovative design and state-of-the-art technology can work together to build infrastructure that not only satisfies present demands, but also establishes the foundation for future expansion and advancement. The astounding scale of the tunnel is highlighted by reports, which state that it is roughly 4 times larger than other noteworthy submerged tunnels, such as the Channel Tunnel connecting the UK and France. The Jintang Marine Tunnel is part of the Ningbo-Zhoushan high-speed railway, which has garnered major recognition for its cutting-edge engineering. Notable accomplishments of the tunnel include its capacity to withstand high water pressure and its title as the world's longest underwater shield tunnel. Upon contemplation of the Jintang Marine Tunnel, it is evident that undertakings of this nature significantly influence the worldwide engineering community. Scale, innovation, and technical prowess together are raising the bar for what is possible in infrastructure construction. This research emphasizes how crucial it is to adopt cutting-edge technologies and creative problem-solving strategies to conquer challenging engineering problems. For example, the unique utilization of vacuum tubes and magnetic levitation in the proposed high-speed transportation system known as the Hyperloop promises to transform travel. In a similar vein, the building of floating cities, intended to fend off the rise in sea levels, is an audacious and progressive method of urban planning. Another area of tremendous interest is the creation of smart cities, which incorporate digital technologies to improve urban living. These cities use technology and data to save energy costs, improve infrastructure, and improve living conditions for their citizens. Urban planning projects such as Songdo in South Korea and Masdar City in the United Arab Emirates are prime examples of this creative technique. The Jintang Marine Tunnel project is a prime example of the strength of cutting-edge innovation and technology and represents a tremendous engineering accomplishment. It has gained the respect of the international technical community and established new benchmarks for the construction of underwater tunnels. As we look to the future, we can expect more audacious initiatives from all around the world to keep pushing the envelope of what is feasible and pique the curiosity of engineers and enthusiasts everywhere. We appreciate you coming along as we explore the Jintang Tunnel project in detail. New benchmarks in infrastructure development have been set by this engineering marvel. How far below the surface of the ocean does the tube extend? Leave a comment with your response. Make sure you subscribe, leave a comment, and like the video. Stay tuned for the next video.